The way we approach fractions is through communicators, through discovery, and very highly sequenced sets of activities. The tools that we use to teach fractions basically are Communicator Clearboards. They are the clear plastic sleeves that you can get. If you don't have them, you can use plastic sleeves. You can buy sheet protectors from either Staples or Office Max or something like that. In conjunction with the Clearboards, we use templates, and those templates are sets of papers that you put inside the communicator. That's a set of fraction circles, obviously, that we'll be working with later on today. Steve already sent you the templates via email. You can feel free to copy those and use those in conjunction with the communicator. We also use line segments. We have kids identify fractions on line segments and mark them with their communicator so we can add, find the equivalent fractions, and so forth. Another model we use are fraction bars that take the idea from fraction tiles. And of course we use rulers, because rulers are just a natural for working with halves, quarters, and eighths and sixteenths. And we also use, as a final thing, fraction tiles. Fraction tiles we recommend getting from either NASCO or Educator's Outlet. So basically, those are the tools that I'll be using today. You'll be able to maneuver things around. You'll be able to write on the screens and so forth. So let's just go over some of the concepts that we're going to be covering today. A little ambitious, I'm sure, but we'll try to get through most of it. We're going to go through the concept of a fraction and how kids discover what the denominator and numerator is. We're going to compare and order fractions. We're going to add fractions with like denominators and compatible denominators. You'll see a lot more of what that means in a little bit. We'll see a discovery way to find LCMs and GCFs. We'll continue with addition. We'll do a little bit of subtraction by counting up, and then we'll look at multiplication, a little bit of division, and if I have time, we'll do some operation games, and then we'll do a little closure. So, what we're going to do is we're going to move on now and just do this a little bit more. The first activity we're going to do is for kids to discover numerator and denominator. The second activity we're going to do is then find out how kids can discover the algorithm to simplify and find equivalent fractions and to deal with mixed numbers and improper fractions as well. After we do that, we are then going to go to addition and subtraction. We're going to do same denominators, and we're going to combine like terms. We're going to treat it like combining like terms in algebra through the fraction tiles. Then we're going to do what I call compatible denominators, where we're going to discover what an LCM is with fractions. Compatible denominators have denominators like 1/4 and 1/8, or 1/3 and 1/9. This will all become clear as we do this. And then we're going to use amazing number machines to find LCMs and GCFs, so we can find an algorithm for that. And after we do that, we'll finish up addition and subtraction of fractions. So that's a little bit ambitious. And then we're going to go to multiplication fractions. I do multiplication fractions through area and parts of parts. The kids explore concepts with all of these operations and then do the algorithms. We don't teach the algorithms first. We want the algorithms to be a recall of reality. So anyway, area and parts of parts is what we use. And we sequence the activities quite, they're highly sequenced. So the kid, you can see we do unit times unit, unit times proper, proper times proper, and so forth. We won't be able to do all those today, but I just wanted to get that point across of how we sequence. And then we get to division. We look for, we do sets of problems with remainders and without remainders. And we then we divide whole numbers by unit fractions. Then we do whole numbers divided by proper fractions, and then proper fractions. The idea is you don't have to remember all this. It's just the idea of you seeing all that sequencing. And finally, we're going to get to what we call a fraction bonanza. The whole idea of doing fractions from what our point of view is to get kids to be able to realize that there's times they want to use mental math to do fractions. There's times when you want to use little paper and pencil exercises. And there are other times when you want to do estimation and then use a calculator. We are going to concentrate on the mental math and paper and pencil activities today. So that's a little overview of where we're going. the whole idea is that we want to keep in mind that we're conceptually based, moving into algorithms rather than the other way around. So the first thing we're going to do, I'm just going to change some screens on you for a second. We're going to go into a smart application. So I'm going to stop the PowerPoint, and I'm going to bring up a smart application. And just hold on a minute, and we'll go right to there. Oops, and why do I have a pen? And now we're going to go into the smart application. Just hold on. There we go. Smart should be coming on your screen in a second. And there we go. And you will see a another screen come up in a second with the activity in it. And there we go. Okay. So it's loading the smart activity. And we're going to talk about a couple of things. We talked about some of these already. And one of the things we are going to take a look at are these line segments. And again, we send you this template. And the first question that I ask kids when we give this out is we ask kids, what do you notice about these line segments? Is there anything that you notice, that you observe? What I'd like you guys to do is type into the chat where Steve has been communicating with you. Type into the chat and send it to everybody so they can see it. What are things that you observe about those segments? It doesn't have to be anything sophisticated, but we'd love to hear from you, and just type in what you observe. And we're looking for responses. Okay. Kathy, we hear from Kathy. They're all the same lengths. Anybody else have any? They're all the same lengths. Chris, no numbers, and they're equal in division. Okay, that's great. And that's exactly what the kids would do. They would do this on their communicator, and they would hold that up so you would have an idea of what they're doing. Then the next thing we do, you're absolutely right. You guys can stop responding now. But they're all exactly the same length. They're all what we call unit line segments. They're all 1 unit long. And you're absolutely right. We want to stress that they're divided into equal parts. But then I put this on the board. I put a line with a 2 under it. And then on this one, I put a little segment with a 4 underneath it. On this one, I put a line segment with an 8. On this one, I put a line segment with a 16. On this one, I put a line segment with a 3. And then I stop. And then I ask kids, well, what do you think this means, and what number would I put under my line here? And through questioning, we get from kids that the number at under the line seems to tell us how many equal parts the segment is divided into. So the one way on the bottom, obviously, would be divided into 25 parts. And then we go on to a new interpretation. We just go on to another one. Now we get into fraction bars. Same idea. We ask kids the same question, but they're saying here that they're all the same unit. They're unit bars. And we still want to use the same kind of notation. Like on that one, how would I describe that? We have kids answer that on their communicator. But the whole idea is that we're introducing the idea, obviously you know, of a denominator. But they're not really doing anything with numerators yet. We're just only talking about denominators. So we get across the point. The denominator divides a unit into an equal number of spaces or parts. So here, obviously, this one would be a third. This one the kids can label as a sixth. This one we have the kids label as 1, 2, 3, 4, 5, 6, 7, 8, 9, and then so forth. This one I think is 12. So we finally define the term of denominator, and I think they have a working idea of what they are and the units that we can use. Obviously, there are other units we can use, but circle, line segments, and bars seem to be okay. After we do that, we're going to go now to another activity where we actually but we ask the kids to respond to different kinds of questions. So here, what the kid does is you give the kid this model, and you show this using the notebook software, and you say to the kids, I want you to circle the segment that shows 16ths. And again, if you want to write it as I have at the board, at the top there, or obviously you could just write it as 16ths. And then hopefully the student would take this, and then you can, then they would hold up their communicators, and of course you would circle the one that has 16ths. So just for the fun of it, and I know you know the answers to these questions, I'm going to get you all involved in an activity. So I am going, and just to test your knowledge on denominators, but just to get us involved, what I'm going to do is I'm going to stop this SMART presentation. So your screen should go white, and I am going to bring in a fraction bar. Okay, on your screen you see a fraction bar that says mark the unit rectangle that shows 16ths. In order to do that, we're going to put everybody into a breakout room in a minute. And when you get to the breakout room, you need to be able to move this rectangle around. I just moved it. You can see me moving it on your screen. And if I wanted to answer the question I just had and I wanted to go to 16ths, I would find the one that shows 16ths, and then I could even make the bar bigger, and I could show the answer to be 16ths. But when you get into your breakout room, you're going to have a different question, and you'll want to know how to move this thing around. So we're just going to give you a little bit of an overview of how to do that. So just give me a second, and we'll just give you an overview on how to move the things around. It's going to be a PowerPoint that you'll see come on your screen in a second. And it's a little black on the right corner there. I'm going to bring in our PowerPoint that shows you how to do this. Okay, and now, when you use Illuminate, and that's the software program we do deliver this, what happens is that whether you have an object and you want to move that object around, you have your cursor there on the screen, and you see the object. If you want to move that, you position the cursor either on the edge or the border of the object, or in the middle of it with Illuminate. On Smart, you do something else. But then you also click the left mouse once you have once you're there, and in the center or on the border of the object, the cursor will change to a hairline, crosshairs, and basically what you need to do is then click your left mouse, hold it down, and when you do that, you can move it anywhere on the screen that you want to move it. And to then anchor it, what you do is just move the crosshairs out, and the cursor, it comes outside as an arrow, and you've anchored it. So again, you take your cursor, put it inside, it changes it to these crosshairs. You hold down the left mouse, and you can move it anywhere you want on the screen. And then to anchor it, you just move your cursor out, and it becomes back to a cursor. To resize an object, what you do is, again, you position the cursor on either the outside or the inside. It'll change to those crosshairs, but now you move the crosshairs to one of the vertices. You can see those little line segments and lines on the corners and the vertices. If you move the vertices, if you move the different vertices, you get different kinds of lines. And if you move to the horizontal one, the one we're interested in today, the one's right there where my cursor is pointing, you can hold down your left cursor and change the size of the object. So for example, what we're going to do is I'm going to resize this by, again, I put my cursor on, I then took my crosshairs and put it on the vertex to change it to a line that you see there, and then I can extend it. So we're just going to practice with this really fast. What we're going to do is I'm going to take the PowerPoint off, and we're just going to practice this real quick so everybody feels comfortable doing it. And now I'm back to my model here. I am going to put on the board a yellow rectangle, and then I'm going to put on the board a not a different color. I guess that's shouldn't have picked that color, but what it is. All right, now what we're going to do is I'm going to ask somebody to take their cursor, and they're going to move the yellow rectangle around, and they're going to make it the same size as the turquoise one there. So the first thing you're going to have to do is on the left-hand side of the white screen, immediately to the left, you see a whole bunch of tools, and the one below the little arrow is the one you're going to use. You're going to click that arrow, and that will give you a cursor on your screen. So the arrow will be clicked, and then you are going to move your cursor to the yellow rectangle and press the left button. You'll see a line go around it, and then you can move it. You can't see that on my screen where all the stuff is there, but you can actually move that, and then you're going to press your cursor and move it to the right. Okay, and somebody's been moving around on me, I think. So there we go. All right, so one at a time. What I'd like you to do is Kathy, or do we have a volunteer first of all who wants to try this? Just raise your hand if we have a volunteer who was going to give it a try here. All right. Number one is Louise. Louise, I want you to take your cursor and put it on top of the yellow rectangle. Press the left key and then move it down. So there you go. She moved it. Now take it and move your cursor over. There you go. And she made it the same size. So excellent job. Let's give Louise a round of applause. Everybody, the applause sign is next to the little man there. There we go. See if there's an applause sign next to the hand. And there we see people giving the applause. Okay. We're going to ask for another volunteer. I'm going to redo these, so please don't touch it until I ask you to. We're going to go back. And now let's move it up. Okay. So number two, Kristen. We're going to ask you to try it now. She moved it down. And now she's going to try to make it larger. I think she made it disappear. Okay, let's try it again. Let me put another, there we go. And now just what you're going to do is go to the vertex at the, you're going to move the crosshairs to the vertex at the right in the middle. Hold it down and then stretch it. Try it out and see if you can get that to do that. There you go. All right, let's give Kristen a round of applause. All right, you guys, the applause sign is right next to the, there we go. All right. So we're going to ask for one more person to try it out, and then I'll go back over the rules, and we're going to actually do the problem. Okay, we have one more volunteer. Somebody who hasn't gone yet will help you out. How about Christina or Espoli or Yvette? You've been in almost every workshop we've done. You know, why don't you take a chance to do one? Three. Kathy's going to try it. No, Kathy. Okay, Kathy, give it a try. Move it down first. Place your cursor on there you go. She moved it down. The hard one to do is then take your crosshairs and put it on the little square on the outside of that surrounds it. There you go, and hold it down. Excellent job. Give her a round of applause. I'm moving it back now. And let's see. We have somebody from Mitchell Elementary who'd like to try it. Okay. Just raise your hand, Mitchell. All right. Okay. Mitchell says chat. She says they say okay. Give it a try, Mitchell. Go ahead, Mitchell Elementary. There you go. Now click on to the cross. There you go. You guys are pros. It's not as smooth as a smart board, but it does do the job. So after all this work, what we're going to do is we're going to put each one of you into a different breakout room. You will receive a problem to do, and then you are going to move that rectangle back like I did up here. What you're going to do is, this is the problem that we did together. I think that was the problem we did together. It was 16ths. And what you're going to do is you're going to take your rectangle and you're going to move it to the answer. And then you're going to extend it so it takes the whole line. Okay, this is the reason we're spending so much time on this because we'll be doing this more than once today. Okay, but kids would be using their communicators. They wouldn't be going through all this confusion with the webinar um, directions. All right. So anyway, we're gonna send everybody to a breakout room, and then you're gonna receive the problem. Steve and I will come into the breakout rooms and help you out. When this happens, you will not be able to hear me until I get into the room with you. The way we communicate with everybody when they're in breakout rooms is through the chat. So you have a couple of minutes to complete the problem. I'll collect all the answers, and we'll bring you all back to the room. But please remember, there will be silence for about 30 seconds, and there will be nothing on your screen, and then all of a sudden you'll see the problem come up, and you'll give it a try. Okay, any questions before we get started? All right, you guys are good sports, so let's give it a try and see how we make out. So here we go. We're going to, we got to do one more thing here. And we're going to, okay. We're going to, there we go. We have breakout rooms. You've now, we can go into the rooms now. Okay, everybody's back in the room, and we're just going to check out some answers. Nobody will know what group you were in, so don't worry about it. But we're going to take a look at some answers. This is what you would do with the communicators. So we're going to look at answers for, oh, I don't know. Let's look. Nobody again will remember what group you're in. So let's see. Group 2. Let's see. We have a group 3. All right. Group 3 answered with the answer at the bottom, which is the 25th. Excellent job. Okay, we can check out the answer for Group 6. I don't know whether there was a Group 6. Group 5, whoops. And we want to look at Group 1. There we go. So the idea is that you want to move that around, and then we can test it out. But the kids obviously will be using those with communicators, and you can tell whether they can give you the tell what a denominator is. Obviously, after we do denominators, I'm going to just do a couple things here. We're going to Louise, do you have a question? Okay. Okay. Oh, she doesn't. Okay. And Kristen got a little confused, but you're okay now? Do you have a question? You can type as a question. Okay, good. It's a little confusing to get you guys oriented in such a short time to illuminate, but you're doing a great job. But I like to have that participation. So we're going to I just have to do a couple of things here. We're going to go on to our next part here, and just give me a minute. I have to do some housekeeping things on here that you can't see, and we're going to just clean up the room. All right, and you have a white screen on your screen. Okay. We're going to take a look at then start using the same kind of concepts to discover enumerators. So again, if I just call up a smart file here for a second, and we can look at that smart. Oops. All right. And we want to again take a look at the kinds of things that we have here. And the only extension that you have is to use the same idea, and after you've established the denominator, you can start working with proper fractions. And again, you can draw a segment that shows 3/5. And what I would do is I would have the kids go down to realize that, well, if I'm on fifths, that must mean the line I'm going to choose is divided into fifths, and I would draw 3 of them. And then I would go to the next one, and there's the answer. And then I could show them 7/20ths. So I would find the 20ths, and then I would go and I would take that and go to 7. So I have 1, 2, 3, 4, 5, 6, 7. And then they would get the idea of what that top one means. We could do the same kind of problem without line segments. We can do it with the bars. You can have the kids use these in their communicators. They could show us 5, 6 by just highlighting 5 of those. So after doing a couple of these, then you ask the kids to think about what they see and what they think about that top number in relation to the bottom number, and then they tell you that the denominator is the one in the bottom, and the denominator is the one that divides the unit into an equal number of parts, and the numerator is the top one, and the numerator is the one that tells you how many of those parts are being referenced. And again, you could, practice these, have the kids hold up their communicators, but the whole idea is you want the kids to discover the roles of those of the numerator and denominator rather than just telling them. Okay, we're going to go on to another activity now where we're now going to look at for equivalent fractions and simplifying fractions. And I'm going to bring up a new Smart file. So just give me a minute to bring that up. And basically, I'm going to do an activity where we create fraction bars, and we create what we call a unit stick. So I'm going to bring this up. You should be able to see a unit stick on your board, but I'll explain that. And now what I'd like to do is there we go. Okay, where are we here? I somehow screwed that over. Here we go. All right, there is creating a unit stick. The way you create unit sticks is before class, you cut sets of 4 2-inch strips of construction paper for each student. And the way you do that is it's best to use 12 by 18-inch pieces of paper. And what you do is you put those sheets on top of each other so that they are all one sheet. And then you go to your paper cutter, nice and neat here, and you have all 4 sheets on top of each other, and then you cut them into 2-inch pieces, which will give you 9 strips. When you then separate them, you will have a 12-inch, 2-inch high by 12-inch red, a 2-inch high by 12-inch yellow, blue, and white. Each kid gets those 4 rectangles, and then we are going to develop along with a marker and pieces of tape. So that's the first thing you have to do. So you get 4 pieces of construction paper, and each one of those 4 sheets will make 9 sets for the kids, because there's 9 times 2 is 18 inches. So you can make as many sets as you can that you need for your class. Every kid should get one with a marker and some tape. So after you get that accomplished and get them handed out, you tell the class to choose the red rectangle. And you explain that that rectangle has an area of 1 and it is the unit 1. You tell the class to fold the rectangle in half, and you model that. And then you open the rectangle, tell them to open it. And then you tell them that you are going to ask them to look at the fold and to mark it with a marker. So that is the red one is marked in halves, so to speak. Okay. Then you tell them to take the yellow one. The color really doesn't matter, but it keeps it more orderly. And yellow, you're going to now fold into quarters. So you tell them and you model how to fold that into quarters. After you do that, you open it up, lay it flat on the desk, and you see your 3 folds divided into 4 equal parts. And then you use a highlighter to mark the 3 folds to show clearly the quarters that are there. Then you take the blue one, still the same unit, still same size, unit 1, and you divide that into 8s by folding it 3 times, obviously. And then you open that one up, and you have your 8 equal parts, 7 folds. And then you ask them to highlight those 7 folds. And then you move to the white one. And this one is folded into 8s first. And then you open it up as a little book like that. And then fold this in the inside, the sides in. So it's easier for them to see the 16th, but the point is you fold it into 16ths. There'll be 15 folds and 16 equal parts. So they mark those. So now every kid now has a sheet units that's divided into 16ths, eighths, quarters, and halves. So what you ask them to do now is to put them together. There they are. There's your 16ths, your quarters, your eighths, and your halves. What you want to do is, technically, I have that in the wrong order. The eighths should be there, so when you put them together, they'll be right. All right, now what happens is you overlap them. So I'm going to overlap that one like that, overlap that one like that, and overlap that one like that. Now, the ones the kids make will not be as neat as this probably, but they still can line the little line segments. And obviously, they look like the one I have there at the bottom. Once they have those aligned, and you're modeling this as they're doing this, I've done this in hundreds of 4th, 5th, 6th, 7th, and 8th grade classes, and it really works very well. At any rate, what you do then is you tell them to use the pieces of tape. It is best to tape them diagonally or vertically, not horizontally. So they can tape the back of it. Notice how I turned it over. They can tape the back of the front or the back. It doesn't really matter. But usually they like to tape the back where the markers aren't. But anyway, they tape those together, and now they have their own unit stick. After that, you have them put it in a Communicator Clearboard or in one of those plastic sheet savers, and you have them then start to mark. And you model this on the overhead or on smart technology. You have them X out 1/16 and mark it to be 1/16. You have them mark out another X and mark another 16th, and then that's, of course, 2/16. You ask them what else that equals, and, of course, 2/16 equals 1/8. So you're establishing equivalent fractions. There's your 3rd 16th with your 3rd X, and then we are going to go to 2/8 or 1/4. I'm not going to do the whole thing with you, but when you get done, you have 16/16, and kids can see that 2/16 is an eighth, 4/16 is a quarter, 2/8 is a quarter, 8/16 is a half. Get the idea of what I'm trying to establish. But they're doing this on their Communicator, and they're establishing this. Once you get that done, then you can ask questions on whether they understand the problem. Based on the unit stick below, name another fraction that equals 2/16. So on their Communicator, every kid would hopefully write 1/8. And if you want to check that, and you're using smart technology, you can just highlight the eighth and show it as the eighth. So the next one would be, what's another name for 4/16? Could be a quarter or 2/8. So I can highlight those and just show the answer. So the question might become, how do I get that to do what I just did with smart? So I'll just take a little diversion here. What you would do is you would go to text, and let's write down a fraction, 1, and then I'm going to underline it, and then I'm going to hit return, undo the underline, and do a quarter, let's say. So that's going to be my quarter. So let's say that's my answer to my question. I did that through text. How I get it to be covered and then disappear is I go to my notebook toolbar, and I go to Shapes. And I click on Shapes, and I go to either the square or the rectangle. I highlight that, and I'm going to now have a little cursor on my screen that will make, whoops, I didn't do the circle. I did the circle instead, so let me correct that. I could put it in a circle, but I wanted to do the rectangle. I don't know what happened there. Let me cut that out. And let me go back to Shapes on the notebook toolbar. I go to the rectangle, and now I have a rectangle highlighted, so it'll work. And I just make a rectangle around my fourth. And now I go to the toolbar, and I go to Select Tool. I go to my shape. I can move it off if I want. Notice how my cursor changed to a crosshairs. When I go on the outline, I click it. I hit my drop-down menu, and I go to Properties. And with Properties, it says Fill Effect. You go to yellow, let's say, and then you can click out of that. So I can put the yellow on top of it. The question is, how do I get it to disappear the way I did? You can move it off, of course, but how did I get it to disappear? Well, let's do that again. We're going to notice how the crosshairs are there. I'm going to right-click. I'm going to go to Properties. I'm going to go to Object Animation. I'm going to click on Fade Out, and let's see what happens. Okay, so now, there it is, and when I click on it, what happens? It fades out. That's exactly how I did this. To renew those, you just go back one page and bring it again, and they automatically renew, and they would be your model for your answers. So again, how did I do that? I used the text on the notebook toolbar to make 1/4. I used the shape maker on the toolbar to make a rectangle. I clicked on that, went to Properties, I filled it with yellow, and I went to Object Animation, and I made it fade out. And basically, you can try those with other things you might want to do in your class. Any questions or on what I just did? The little smart feature there. Okay. What I'd like you to think about is something just happened here. And okay, let me gotta get out of this. Hold on a minute. We're having a technical difficulty here. But okay, you should see the smart come back on your screen. Just had a technical difficulty there. And now, the other thing I want to just point out is other ways you can do equivalent fractions. So let me just pull this back up. Okay. Okay. And now we're going to just look at one more way to do equivalent fractions. We're going to go way down here. Okay. Oh, one other thing I should point out is when you then want to make a transfer to the template, because the templates aren't colored, you can just use your smart technology to use your fade out. And I have a template that shows all of the parts they just did, but without colors. So there's your 16ths, there's your eighths, there's your quarters, and there's your halves. Check for understanding. You can give kids problems where they have to draw the segment to show 7/16. So again, what you would do if you were doing smart technology is I did infinite cloner there. The kid wants to show 7/16. They're doing this under Communicator. And there you have, whoops, I just screwed it up. I should have left it alone. It was 7/16 when I brought it down. All right, the next one is 5/8. So the kid, again, brings down, they clone that. And there's 1/8, 2/8, 3/8, 4/8, and I need 5/8. So do we have a volunteer to show us 1/4? All right, raise your hand, and we'll give you permission to use the smart technology and move it around. Oh, come on, somebody's got to be a volunteer. There we go, Christina. We're going to turn it over to you, and you're going to show us the answer for 1/4. All right. I just didn't want to do that. Hold on. Let me see. There we go. All right, you have permission to do it. Go ahead. Hold on a minute. I got to get the board off of there. There you go. All right. You're going to go up to the top and grab a line segment. Way there at the top. There you go. You're going to clone that. There you go. And you're going to bring it down to show us 1/4. So move it over to the edge there on the 1/4. All right. Bring it down to 1/4 so we can actually see the 1/4 mark. There, we'll bring it over. There you go. Excellent job. Bring it down to the 1/4 mark itself. Way down at where the 1/4 is, just so the kids, it is 1/4, there's no question about it. It's 4/16, it's 2/8, and it's 1/4. All right, give Christina a round of applause. All right, there we go. Steve gave her a round of applause. There we go. Okay, so you can bring it down and mark it right there if you want. If you want to straighten it out, you can just straighten it out like that. Okay, or you just leave it where you had it. It was perfectly fine. All right, so you can have the kids do that so you can see if they can get the quarters. It's a great way to teach rulers also, by the way. So then we move on, and we start to go to a different kind of template. I'm going to skip the ruler activity, but I do want to go to do some equivalent fractions with, there we go. I want to do some equivalent fractions with with this template. When you look at this template, this is called the fraction decimal template. And as you can see, I have line segments on there, but let me move the line segments off. What's cool about this is I make the analogy between the ruler they just made when they used the red and the white and the yellow and the blue. I make an analogy and tell them that each one of these strips on here, if I just use a little shading here, each one of these strips were a piece of paper that I just copied and put on this template. That was a 1. Remember when we had just a red piece of paper, and then we divided it in half, we folded it and marked it? Well, I just copied it. We didn't do thirds, but how do you think I would have done thirds? I would have taken a new color, and I would have what? Folded it into thirds, and then marked each one to be a third. It was fourths. We did those in our model with yellow, and then we fold those into fourths and mark them. You can mark them. So I've been a nice guy. I made some for fifths for you, some sixths, some sevenths, some eighths, some ninths, some tenths, 12ths, 16ths, and then even hundredths here at the bottom. So this is called our fraction decimal equivalent sheet. To find more fractions that are equivalent, what you want to do is take your line segment and put it on a half. Then have the kids either move the communicator down or draw as many line segments that will show a half as possible. Like 2 quarters must be the same as a half because the line ends there, and it's the same length. Oops, it's the same length as the half that you already have, but basically it is a different name, 2 quarters. You can clone that, and you can bring it down to 3/6. You can clone that, and you can bring it down to 4/8. Or you can have the kids move those up and down. But the point is you have them move those around. And what happens is you can even have them do it with a marker like this. You can model this with the smart stuff. And you can clone those. And again, you can mark them as a half, a quarter, and so forth. If you wanted to show the answer, you can just click on that, and all the answers that are equal to a half are right there. So a half has many names. Numbers are the masters of disguise, we tell kids. So we write them all down. And we show them this sheet that says a half is equal to 2 quarters, a half is equal to 3/6, a half is equal to 4/8, and so forth. And then we ask them to look for a pattern. And when they look for a pattern, what they're doing is hopefully they talk to each other in groups, and they start to talk about the fact that the way you can get 1/2, I should go back and do this. If you can get 1/2 to be 2/4 is you can multiply the top number by 2, and you can multiply the bottom number by 2, and I'll be darned if that doesn't become 2/4. Here I can multiply the top number by 3 and the bottom number by 3, the numerator by 3, the denominator by 3, and it becomes 3/6. Here I can multiply the numerator and the denominator by 4, and it's 4/8. Here I can multiply the numerator and the denominator by 5/5, and it becomes 5/10. So hopefully through your questioning, kids will discover that. And basically, what is 2/2, 3/3, 4/4, and 5/5? Obviously, it is a form of 1. It is the multiplicative identity element. So you can summarize that on the next sheet by actually showing them 2/2 is times 1/2, 2 is 2/4. So you can show them all of the forms of 1 that would work. That is one way to find an equivalent fraction. So I made up this sheet for kids to practice. You can do this as a give and take, but you can have all the kids respond on the communicator. But here's how you work this out. Here I made this up, and I have an infinite cloner over here on each one of these fractions. The idea is that you have to take the form of 1 that would make it into its equivalent. What do I have to multiply 1/3 by to make it 2/6? Well, if I multiply numerator and denominator by 2 over 2, I can get 2/6. What do I have to multiply 1/5 by to make it 4/20? I'm going to multiply by 4 over 4. What do I need to multiply 1/4 by? I need to multiply by 3 over 3. Now, I'm not going to do them all, but if you want to then go back and check them, same technique I used before is right there. You can check. There are other things you can do in SMART that would make it interactive as well. But you want the kids to answer those on the communicator, and then you can use the SMART technology to validate answers. But obviously we are using a form of 1. The only other thing I'll just mention on this is that it works the opposite way around. If I have a fraction of 5/10 and I want to get another name, a simpler name for that, I can think of that as multiplication. I can think of 5 times 1 over 5 times 2. And then I have my old friend of my form of 1, 5 over 5 times 1/2. And that is going to give me a 1. The 5/5 becomes 1. And that becomes 1 times 1/2. And that becomes a 1/2. This is very, very algebraic and is a great way to teach kids how to simplify fractions. It just sets the foundations for later work in algebra when kids get into rational expressions. But I won't get into too much algebra here. So anyway, we've now done equivalent fractions. So we've established numerator and denominator through discovery. We've established making fraction units, so we could find equivalent unit sticks, so we can find equivalent fractions of 16ths, 8ths, and quarters. And now we have done it with the fraction decimal template. You have all those templates that have been sent to you. And now what we're going to do, basically, we're going to now go into some addition. So I'm going to bring in a new file. And I am going to bring in my file for addition and subtraction. So I'm just going to go to adding like denominators. These are fraction tiles. And my fraction tiles, if you turn the fraction tiles around, they don't have, some of the new ones have stuff on both sides. The older ones don't have any names. And you can have the kids mess around with trying to guess what they are. You can take one and you can just clone those with the infinite cloner, and you can see, well, there's 2 of those, so the brown ones must be a 1/2. If I slide the red ones over, how many red ones can I get? And you can just have the kids mess around with those, have them turn them upside down, and have them decide what they are. You know, have them turn them upside down in a sense so they can't see them. And obviously there's 8 of these that'll fit, so these red ones are 8s. So eventually they'll see the actual answers. They're all printed. These are the ones that are sold by Educators Outlet and NASCO. And they come in classroom sets of, they have an overhead set, but you're going to be using the communicator. I mean, you're going to be using the these simulated manipulatives I've made for SMART. But at any rate, they're all the same color, they come in kits and that kind of stuff. So the idea is you want kids to understand how to add like denominator, like fractions together. So on the bottom I have an example of 3/5 and 1/5. If I have them think of these as tiles, there is my set of 3/5, and there is my set of 1/5. If I want to add them together, it's like combining like terms in algebra. You don't have to tell them it's combining like terms, but what you want them to think about is they're adding items together that are called fifths. And when you add them all together, what do you see there? You obviously see 4/5. So you get the idea that that's how they avoid adding a fifth to a fifth and getting 2/10, because they see it as, well, I have 1/5 there, I have another fifth there, I have another fifth there, I have another fifth there. I think of that as 4/5. If I wanted to do it on a decimal sheet, I can think about this Basically, you can use this as a ninth, and you can go back, and we have ninths. And now I have 1/9, and I want to add that to 4/9. I can just take that and put my segment on there, and I can drag that over to 4/9. Somebody has a question about Cuisenaire rods. We don't have those made up yet, but I could make those up for you. I don't use Cuisenaire rods as much as I use the fraction tiles, but absolutely Cuisenaire rods can be used. I use Cuisenaire rods a lot for decimals, but you can use them for fractions, no question. But I happen to use fraction tiles, but we can make those up for you. So anyway, this is a 1, 2, 3, 4 ninths, and 1/9 is going to give you an answer of 5/9. So, adding like terms together, you can use the other line segments, 1/6 and 4/6. You would just make a segment with the communicator on 1/6. You would then add that to 4/6, and the kids can model this like this. And the kids should realize that what can they do? They can add those together without really using a model. 1/6 they can think of as a segment that is 1/6 of a unit long, add it to 4 segments that are each 1/6 of a segment long, giving you 5 segments. The idea is that you just don't tell them to add numerators, even though that's what you're doing. You want them to understand the concept that is behind it. I'm going to go on to another interpretation here. Basically, once you get them to add like terms, you then want them to start to think about adding ones that are not same denominators, like 1/4 and 3/8. Here, the way you do is on a fraction decimal sheet is you take 1/4 and you mark 1/4 with your segment. And then what you do is you take that 1/4, and because you're going to be adding that to 8ths, you slide the communicator down. You're actually going to slide it down. I'm just sliding the line segment down right now, but you slide it down to 8ths. And that magically changes the what? The quarter to what? 2/8. And then what you can do is then add to that 3/8, because that's what you want to add. And the entire answer is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 8. So kids can model that. So let's just see if we have some audience participation and do a 1/3 and 1/9. So we need a volunteer. Anybody want to volunteer? And I'll lead you through it. And we'll show how to add what we call, all right, let's see, Kathy. All right, Kathy, we're going to give you permission to use this. So we're going to give you control. All right, and just give me a chance to get that black thing off the screen over there. All right, now, grab the red marker, the red one, all right, and put that on a 3rd. Notice how she moves it over. You're doing this on your whoops. I should have anchored that. Just give me a point. Let me have that a minute, and I'll anchor it for you. My mistake. I should have anchored it first. Just let me lock that in there. I thought they were all locked. I apologize. Go ahead. Keep going. All right. Move it over. Excellent. She's got that on a 3rd. Now, we need to add that to 9th. So she is going to, what? Move that down. Now, actually, the communicator moves, but right on this one, you're just moving it down. Notice how the 1/3 became 3/9. Think about how much understanding this has for kids. All right, now go ahead and move the blue one. And you're now going to add 4/9 to that. And the kids would be drawing this on their communicator. They're not moving this stuff around. And now they're going to go and extend that to be 4/9. All right. Something happened there. Let's see. Just grab. There you go. There you go. And we're going to do 4/9. Excellent job. All right. And just there you go. And of course, our answer when we read those would be 7/9. Give Kathy a round of applause. That's the applause button right next to the hand button. There we go. We're getting into it now. All right. This is great. Okay. So you can see that we can add unlike denominators. These are called compatible denominators, and we'll get to why in a second. We can do the same thing on our line segments. Let me show you a quick one on a ruler. If you're really brave, you can do these on a ruler. 3/8. You take your line segment and put it on 3/8. So that's 1/8, 2/8, and I'm going to bring it over to 3/8. You put on 3/8 there, or you can bring it up to be 3/8. And then I want to add to that 1/8, 2/8, 3/8, and I want to add to that 5/16. So again, you can do this, and you can add 5/16 to it. Let's see, we have 1/16, 2, 3, 4, 5/16. And the answer obviously is 3/8. I covered that one up a little. So you have 3/8, which is 6/16 and 5/16 more, which would be, of course, 11/16. A little rough there. Okay. Now, when we finish these, we show kids this sheet. I just had it on the screen a couple of minutes. There we go. We show kids this sheet, and we have the set of problems that they just completed using either the fraction decimal sheets, or they use the rulers or whatever. But the point is, we show them the answers. 1/4 plus 3/8 is 5/8. 1/3 plus 4/9 is 7/9, and so forth. Then we ask them to study the denominators in the problem and compare them to the denominators in the answer. What do they notice? Even though they're different, what do they notice about the denominator in the answer? Well, I'm going to tell you, but we want kids to write and discuss that in groups. We don't have time to do that. But they say, oh my goodness, the denominator in the answer is one of the two denominators. And it just happens that the one that is the answer is the multiple of the other one. That's why I call these compatible denominators, because it's easy to find the LCM. Notice how different this is from the way most textbooks teach this. This is very intuitive, and I'm not really doing any algorithms until we get all done with them explaining how to do the problems and understanding the concept. So, if I were to give you a new set of problems to add, like 1/5 and 1/10, I would ask kids to tell me what do they think the denominator of the answer is going to be, and hopefully they would tell me it would be tenths, because this is the multiple of the two of those numbers. They are compatible. One is a multiple of the other. But if you wanted to act that out with fraction tiles and they know the denominator is tenths, they would build a 1/5 or they would build a 1/10. You want to add those together. We found out on our previous work that we have to change them so they're all the same denominator. What is 1/5 is tenths? Well, if I multiply numerator and denominator by 2, I get 2/10. Or I can just pick up my tenths and make the equivalent of 2/10 for 1/5. I could take that away if I wanted. And now I add my other tenths, and I get 3/10. Let's try another problem. All right, we're going to ask for another volunteer. We'll lead you through it. Somebody who hasn't gotten it. How about somebody from the middle school has dropped out on me. Let's see. Is that right? Yeah, okay. How about Foley? I guess it's Susan Foley. You want to give it a try? Raise your hand. Give it the old college try. There we go. All right. We're going to give you permission to move it around. We'll help you out. Okay, so we're all here, friends together. So I'm going to give you permission to move it. All right, what I'd like you to do is move the yellow one onto the screen. There you go. Excellent job. Okay, now move 1/8 onto the screen. If you can add that. The kids will be acting this out with their communicators and their model. All right, excellent. Now, we have to decide how we're going to get all those to be, what's the denominator going to be? It's going to be 8ths. So go ahead and now bring up 2 more 8ths to show us that they equal 1/4. Put that right below it if you would, or right on top of it's fine too. But we're going to get rid of those. I shouldn't direct like this. All right. All right. And now you can just bring down that other 8th right next to it. Now bring down what is there, and now what is our answer? It is 3/8. So give, I guess it's Sue. I don't know your first name, but why don't we give her a round of applause? That's excellent. All right. So you want the kids to act those out, and then you're going to move over to the LCM. All right. I am going to skip the next 2 exercises with addition and subtraction. I'll explain to you another thing we're going to be doing. We'll give you more work with fractions, because I do want to just share with you how you can show concepts of multiplication and division using fraction tiles and so forth, and area. I think we need to look at that, and then that will sort of complete all the operations at least. So I'm going to bring up a new file on Smart, so just give me a minute. And we're going to go to multiplication. And now my multiplication files, basically, we're going to there we go. All right, we're going to think about an area model for multiplication. And we know that in a rectangle, the area of a rectangle is the length of the height times the length, but the length, it's the dimensions multiplied together. It's the length of the height times the length of the width. So I'm going to capture that idea, but the way I'm going to do that is I want to show an area model to show the product of a half times a third. I'm going to take a line segment, and I am going to divide that into thirds because I'm going to multiply, I'm going to estimate thirds there. So I take a line segment and divide that into thirds. I take a vertical line segment and attach it, and since I want to multiply by a half, I mark it roughly in half. Now, it doesn't have to be perfect. Once I have taken one line segment and divided it into thirds, and the other line segment and divided it into halves, then what I do is I complete the square by just moving my, kids are doing this on a communicator, but I'm just making my square there. What I then do is I draw a new line down. So I'm going to just extend this line, and the kids would just extend it with a marker. And it doesn't have to be perfect. Obviously, when I do it, it's not exactly perfect. And then I'm going to do it this way. So now I have a square that is 1 unit by 1 unit, because remember, divided the one line segment into thirds and halves. And so the area of the whole square is 1 unit, 1 square unit, but it has been divided into 6 parts, and it has 6 equal parts. So on the outside, the dimension here is 1/2. The dimension across the top, each one of these segments is a third. So if I want to show a rectangle that has the dimensions of 1/2 times 1/3, I can just take this and I can make a new rectangle that shows it's 1/2 high by 1/3 across. That is a rectangle whose dimensions are 1/3, 1/2 by 1/3. What part of the whole is that? Obviously, there are 6 equal parts, so it's 1/6. So 1/2 times 1/3 must be 1/6. So let's try that again. Let's take 1/5. What I would do is, again, I would take my segment, I have the kids draw a segment, and I have them estimate that by dividing it. Notice I use the second one to be fourths, dividing that one into fourths. So I'm going to take this and divide it in half, roughly speaking, divide that into a half, and divide that into a half. So roughly those are divided into fourths. Draw a vertical line segment about the same length, and divide that one into fifths. So again, fifths are a little trickier to do, but I'll divide it. It doesn't have to be perfect, but we'll divide that into fifths. And now I can draw my new lines, and I make my square. What I do now is I divide it into those parts by just extending my segments, and this divides it into fourths, and this one divides it into fifths. Whoops. So what I'm doing is just extending those segments on my smart board. Oops, and I divide that into fifths. And when you draw the lines, it shows you how inaccurate you are, but that's okay. And we can adjust those if we want to. Bring this down a little. Bring this one down a little. We don't have to. I'll show you a neater way to do this in a minute. So now, each one of these on the left are a fifth. They don't have to mark them, but I mark them just to show you guys how clear this can become. And now I would like to make these quarters across the top. All right, so now what am I going to do? I want to show the product of 1/5 times 1/4. I can draw that right. Whoops, I grabbed the wrong one. I draw that right there. And now we are going to do 1/5 times 1/4. There are 20 equal parts here, so the answer must be 1/20. Okay, I want to show you just a couple of things. You can make these much neater by doing one of two things. So I'm going to show you some tricky things here with PowerPoint, with Smart. Notice how neat those lines are. One way I want 3/7 and I want 5ths. So if I go to my notebook file toolbar down here, and I go to Table, and I use Table, whoops, I want to have it 7ths by 5ths. So I'm going to highlight 7. Whoops, I went too quick on that one. Let me get rid of that. Let me delete that. Let me do that again. I go to my table, and I go down 7. 1, 2, 3, 4, 5, 6, 7, and I go over 5 because I want 7ths by 5ths. And I mark that, and now I have nice, neat squares. I mean rectangles. They're all equal. And I did that with the table. I can then, I can then highlight these. I can drag my cursor, and I can highlight 3/7, 1, 2, 7, 3/7 by 4/5. I can then right-click, go to Properties if I want, and I can fill by making them yellow. And now I can show the kids that that is what? Each one of these right in here are 1/7 each. And these guys here are 1/5 each. And my whole answer, since I divided it into what, 35ths, my answer must be 1, 2, 3, 4. It must be 12 35ths. All right, let me review how I did that just one more time, because it is, I mean, if you're not used to it, it can get really intimidating. I want to just go back, and we'll do this one. We'll do an example where we do 3/4 times 5/8. So again, what do? I go down to my toolbar, my notebook toolbar, and I grab the table. I highlight 4, and I go over to 8. 3, 4, 5, 6, 7, 8, and I click. That gives me my 4ths and my 8ths. I then highlight the parts that I want by just dragging it across. I want 3/4. There's my 3/4. 1/8, 2/8, 3/8, 4/8, and 5/8. How many equal parts do I have? I have, whoops, I didn't shade them. We'll do 3/4 by 5/8. Let me shade those. Right-click, Properties, Yellow, and now I have 15, 30 seconds as my answer. Now, just to, I guess, show off, I can also do it if you have math tools. All right, if you have math tools from Smart, make a square, and then clone it. Have 2 squares. Smart tools. You only can do this if you have the math notebook. You can get a trial copy of this, and you click on that. You can right-click. You can right-click this, and notice how it says Shape Division. I am going to divide my first one into quarters, and we'll divide that into quarters. I'm going to divide the other one into 8ths. All right. So I'm going to take my board, and I'm going to right-click it. I'm going to go to Shape Division, and I want to divide this one into 8ths. All right. The trick here is that before I move this, I have to notice how I highlight those with my marker. I just take my cursor, my left cursor, hold it down. They're all highlighted. Go to my right cursor, and I group it. And now I can turn it. This is getting too advanced. I apologize. and I can put that one on top of the other one, and I now have created what I had before. I have my quarters and my eighths. I can then take my yellow one, put it on top, and I can make that go 3/4 by 5/8, and I'll be darned if it isn't the same answer. So again, if you don't have Math Notebook, then you can't do it that way, but you can do it with the tables. But you know, to tell you the truth, with the communicators, I would just have them draw sketches. So anyway, the point is that after we do these fractions, we have them discover, like we did with the addition problems. We write down a whole mess of problems. I think I have these written in a workshop I did. And basically, there's a lot. Let me just write that a couple. We have the kids discover what the algorithm is. We do not tell them. We write down like 1/5 times 1/2 is 1/10. We write down 1/3 times 1/4 is 1/12. We write down 1/7 times 3/4 is 3/28. And we ask them to look for a pattern, and they tell us the algorithm. There are other techniques that I can't do today in this hour and a half that we use to do proper fractions times mixed numbers times mixed numbers. But right now, I want to get that initial area model in for you, so you had an idea of what was going on. So at any rate, the other way to do multiplication is to use fraction tiles. But I think we're going to let that one go just so I can show you a quick division worksheet here. I'm going to open this up to another one here, and I'm going to go to division. Okay, and all right, I'm going to go to one of our first models here. The thing is that with division, we are going to take a look. This is a different model than we had before. If I want to do a division problem, and whoops, I can go back. I can show them on a ruler. Well, why don't I show a couple on a ruler? I want to show how many eighths there are in a half. So I take my ruler. This is pretty brave to do this, but you want to mark down. So let me make this a little bit bigger so we can see it a little bit better. All right, what you want to do is you want to mark it as. Oops, I should bring it down. Is mark it as a half with red. So I mark my segment to be a half. This division is interpreted as saying, like when you divide 21 by 7, 21 divided by 7, you can say how many sets of 7 are in 21? There's 3. Or you take 25 divided by 5, you say how many sets of 5 are in 25, and there's 5. So in this model, we say how many eighths are there in a half? And the way you do that is you draw yourself the half, the dividend, and then what you do is you can clone this blue one, and you want to make it into an eighth. So let me just mark these as eighths here. I'll just draw it so you can see it as an eighth. Right, whoops, that's a line segment that is an eighth. And now what you do is the kids, it's easier for the kids to mark them than it is for me to draw these, but we're going to clone those, and each time I clone it, it's a new eighth. Whoops. It's a new eighth, so I want to just move that up. And I gotta anchor this baby here. And I'm gonna move that up, and I have that as 2/8. And I clone that one for another eighth. See if I can make another eighth here. I want to move that one up. And I'm having trouble moving these, of course. And here we go. My other eighth, and then I have my last eighth. Clone it, and I'm going to move that up. And now I have 4/8. Sorry about the drawing there, but it's easier to do on this one. So let me show you this one. If you do it with fraction tiles, much easier to do. I want to know how many quarters there are in a half. Take out your fraction tile. How many quarters will line up to a half? 2 of them. So the answer, the quotient must be 2. So fraction tiles are much easier to use. 1/3, how many sixths are in a third? There's a third, and I want to know how many sixths are in it. You can just have the kids work that out like that. And again, there's a lot of other work, of course, to division that we're not going to get into. But 4/5. If I wanted to model 4/5, let me do a proper fraction one. There we go. How many sets of 3/10 are in 3/5? So I'm going to take my 3/5 and I'm going to take my tenths and put them below it. So I just line up my tenths. And kids would be acting this out with fraction tiles. You want them to use fraction tiles to do this. And they are really now lining up all your tenths. Now, how many sets of 3/10 are in 3/5? Well, there's one set of 3/10 that I just brought down, and there's another set of 3/10. The other way you can do it, if you don't want to bring them down like I just did to show the 3/10, is you can circle them. You could go to your shape down here and take your circle, and and you could. Oh, I should have taken the other one. And let me take my ellipse, and I can circle them and just show you 3/8 there. I mean 3/10, and I can get rid of this one. Right. And then I can take this one and go 3/10 again by cloning it. And now I have two sets of 3/10. So, basically, you want to, again, act these out. And again, we write down the answers to these like we did before. And we have the kids then look for patterns. This one I do by just dragging these up. 2/3 divided by 2/9. Just drag those up, and you have your thirds. You want to divide those by 9ths, so you drag up a 9th, and you just line up your 9ths along the way. And that would become a 3/9 there. And you can keep doing that by, oops, I got to grab the right one. And you have your 9ths all lined up. And again, you can either circle those, or you can pull them down in sets of 2. There's 2/9. There's another 2/9, and there's another 2/9. So the answer is, how many sets of 2/9 are there in 2/3? There's 1, 2, 3 of them. And I know you're all checking to see if I'm right by actually doing the algorithm, but it is right. Okay. Basically, we did a different kind of manipulative for each one of the operations. We did tiles and templates to do addition of fractions. We did little area models for multiplication of fractions, and we did a little fraction tile work and with manipulatives for division of fractions. It's really asking how many of the dividend are in the, how many of the divisor are in the dividend. We'll do fraction division by grouping. But anyway, obviously, I'm a little disappointed because we didn't get to cover half the stuff I wanted to cover, but we'll get into that in closure here. I want to just get out of this for a minute. Your screen is going to change. And basically, I'm going to bring up a PowerPoint application. So in a minute, your screen is going to change. And I'm going to bring up a new PowerPoint. This is the old PowerPoint that was there a couple of minutes ago. Part of your screen is black. Now it isn't. All right, I'm going to bring up a new PowerPoint, as I said, so just give me a minute. Okay. And basically, what you have in front of you is that we want to be continued support to you guys. So you, obviously, Steve has sent you some templates. We can send you some of the notebook files. They're not all finished yet, but we'll send you the ones that are finished. You can access PD videos online through smartmathlessons.com, and you can always call us at LL Teach, and we can answer questions. So if you go to www.smartmathlessons.com, which is what you've done to actually sign up for the webinar, you know that we have different features here, and one of the features that we want to talk about is training. We can come to your school and we can do a full-day workshop on just all of our coaches and myself are math or notebook certified trainers, smart notebook certified trainers. We can come and do a smart, just teach you how to use the notebook. I haven't done too much of that here. We can emphasize math. We can do a combination by doing both math and a notebook together for customized for different grade clusters. So we can get right to your school and do that training. Obviously, we've done other webinars. This is the last webinar in the model, but we do live webinars. We're going to do another series in a little bit. If you want to go back to past webinars, prior webinars, you click on that, and a list of past webinars come up. We did some multiplication webinar. We did just a template communicator webinar. We did a writing webinar for open-ended responses. And depends on which one you click on. But if you click on that on your www.smartmathlessons.com, you come to this page, which gives you more detail, but you get this view. If you click on that view, you can see the video that we did. These webinars that we're doing are definitely taped and put on our website, so you can watch them over again, or you can tell a colleague about doing those. So please take advantage of that. All the webinars now are going to be up, including this one we just did. Upcoming webinars, we want you to know that this summer we are going to be doing a webinar, a series of webinars on manipulatives. They're going to be 2 hours. There'll be 7 2-hour webinars on Thursdays from July 7th to August 19th. They're going to start at 1 o'clock in the afternoon Eastern Daylight Time. All 7 sessions are $35. That's $2.50 an hour. We are going to start charging for these, basically because we have many people sign for these and very few actually take the webinar. So we feel if there's a little bit of a fee, people will be more committed to taking the webinars. But anyway, there is a free introductory session, 3:30 to 5:30 on June 9th to 11. Just go over all the manipulatives, give you an idea of what each one's going to be. And basically that is going to be this summer, and we'll probably repeat that again in the fall. Product-wise, you can download some of our notebook materials. We'll also send you some files that we used today. You can also just scroll through and you can see some of the things that we have created that you can use. We did some of the game things we did. But one of the other ones, if you go to llteach.com, there's a book called Adventures in Computation that I wrote. And there's 5 different activities. There's mental math activities for fractions. There's convince me activities for fractions. And there's answers only activities for fractions, estimate and calculate, and you decide. This is really where the whole unit that I just did goes to. We want kids to be able to look at a set of fractions in context and decide when to use mental math. And we want them to decide when to use paper and pencil and when to use calculated estimation. Convince me's are cool problems because with convince me's, what they do is we have them tell me why. We give them an answer, and they have to tell me how they know the answer is going to be that. So I have to describe estimation and number sense skills. Answers only, they have to, without actually doing the computation, they have to be able to use number sense and estimation skills to determine the answer. Here they actually estimate the answers and they use a calculator to find the answer. And then here they choose the method they want. It's a great way to daily review fractions. Of course, you can buy sets of communicators from us at llteach.com or on smartmathlessons.com. There is a discount. They usually sell for $22.50 a 10-pack. You can buy them for $16.88 if you are a member. This is only for individuals, not for schools. You can buy erasers. They're usually $9.50. You can buy a pack of 10 for $6.75. Erasers are $5.62, sorry, and the pens are $6.75. You can buy a kit for $124.95, discounted to, I think they're about $110 when they're discounted. And the thing is, they come with 30 communicators, 30 pens, 30 erasers, and the big book of your choice, the big book of templates. Obviously, if you become a member of smartmathlessons.com, you can download all of the 1,000 templates that we've made up. And the other way to get free samples is just click on free samples, and it gives you the same choices as before, just another way to get the free samples of our notebook software stuff. So basically, we want to just end this with thanking you for your time. There is no evaluation form. We used to do those on the old ones. Steve will be sending you, email-wise, an hour-and-a-half certificate for participating in our workshop today. Obviously, you can contact us at loteach.com. We look forward to doing more webinars. We want to get your comments. We want to know how effective these webinars are. I'm having a great time doing them. I hope you have a great time participating. I don't do as much interaction as I'd like because I try to cover too much material. But we also are looking for schools and who are doing summer schools. This is something else now. Summer school. And we're looking for schools that would be interested in us doing a webinar with kids. We've done this before. With kids who want to master, a group of kids that you would like to master fractions. We see it as a 6-week, a 5, 6, or 7-week course for an hour-and-a-half each day. The kids would have to have access to a computer. They must be online. They have to have a headset that has a microphone and a microphone and a headset. And they also would be great to have a smart tablet so they can write. If we get 3 schools or so to pilot this, basically it would be a nominal fee, but it would be a great way. You would need a teacher in the room to get the kids online and to monitor and obviously monitor and do classroom management as necessary and help kids out as necessary. But they would not have to plan any lessons. We would do all that. We've done this before with 4th graders. We're looking for grades 6, 7, and 8 to try this with. About 12 to 15 kids in a class would be great. If you have access to that and you're interested in doing a summer school kind of thing, you should call us so we can talk about setting you up and talking about getting things ready. So anyway, we thank you for your time. We'd love to hear comments from you. You can write us a note. Kathy just wrote us a note, and we would appreciate hearing from you. So have a great afternoon, and 3 minutes over, but thanks for coming to the workshop today. Oh, I'm even getting some applause. This is great. All right, thank you.